Hello. In this video we'll be looking at Kirchoffs laws, and perhaps we'll be looking at them in a slightly simplified manner, which is absolutely fine. Now if we look at his first law, the first law is by far the easiest of the laws, and in a very simple version of that is that the total current entering the junction is equal to the total current leaving the junction. Okay, so that's one version of Kirchoffs' first law. So what do I exactly mean by that? Well, let's start with a circuit. So this is a circuit, and there's a cell, and we have a circuit that looks a bit like this. Let's make it look a bit more realistic. Let's put a resistor in there and a resistor in there. Okay, now a junction are points where there's more than one path for the current to follow. So this is the initial current here, I1, and this will be the current returning to the cell. So here is a junction, and here's a junction, and those are the only two junctions. Okay, and here you see the current will split to I2 and I3, and as it comes back to here, it will also split, and what we'll find, you have I2 coming into there and I3 coming into there. So if we look at this case here, we have I1 is equal to I2 plus I3 at the junction, and here we have I2 plus I3 is equal to I1. Okay, so as you can see, the total current entering I1 junction is equal to the current leaving I2 I3, I1 equals I2 plus 3, but similarly when they join back up again, you add them together and that gives you I1. So that's a simple way of looking at Kirchoffs' first law. Okay, and Kirchoffs' first law is an expression of the conservation of current, because current is conserved, which is really the conservation of charge. It boils down to the conservation of charge, because of course current is simply the rate of change of charge with respect to time. So that's change in charge of a change in time. So okay. Now the next law we'll look at is Kirchoffs' second law. Now the second law can be a lot more complicated. It can involve simultaneous equations, but in fact it may not. So let's start with, we'll start with a statement, or one version of Kirchoffs' second law. I'll give you the most simple one. It's simply equal to the total EMF around a series circuit equals the sum of the PDs across each component. I'm not particularly like that one, so I'll go for a slightly more sophisticated one. That says the sum of the EMFs around any loop in a circuit is equal to the sum of the potential difference around the loop. That's a far better version. Sometimes the revision guides make it so simple it's not really correct. So this is one version, not the total, not the not a more complicated version, but an in-betweeny version. The sum of the EMFs around any loop is equal to the sum of the potential differences or potential drops, potential difference is better, around the loop. Okay, and loop can be interpreted as in a series circuit in very, very simple ideas. So, right, the sum of the EMFs. Right, so very simply, if this was, here's a cell, and that was 6 volts, and we have two resistors. Right, so is equal the sum of the EMF. So the EMFs, well, okay, let's add another EMF to there. Let's add it in the opposite direction. Let's make it a little bit more complicated and make that equal to 2 volts in the opposite direction. So the sum of the EMFs around any loop, well, here's a loop, so the sum, that's 6 volts minus 2 volts, because the minus is in the opposite direction, okay, will be equal to the potential drop here, V1 plus V2. Okay, so 6 volts minus 2 volts is equal to the potential differences, that will be V1 plus V2, which will give you 4 volts is equal to V1 plus V2. So we know that the total potential differences V1 plus V2 must be equal to the total EMFs, which is 4 volts. And that is a simple statement of Kirchoffs' second law. So I'll write above here, this is second law. And the second law is often related to the conservation of energy, because whereas first law is regarding to the conservation of charge, and the second law, which is due to EMFs, and EMFs are related to the voltage, and voltage is energy per coulomb, so it's related to coulomb. So let me remember, so a volt, 1 volt equals 1 joule per coulomb, so that's related to the conservation of energy.